Okay, here we have radicals, lesson 1. So when we look at radical functions, a radical function is a function which contains a radical. The simplest one is y equals the square root of x. And then we look at transformations of this. So this is really a review of unit 1 here. So analyze the function, the square root of x. To sketch the graph of y equals root x, complete the table of values below and plot the points obtained on the grid. But when x is negative 4, this is not defined. We cannot take the square root of negative 4. Same thing with negative 1. So those values of x are not in our domain, so they can't give us output values. When x is 0, y is 0. When x is 1, well, the square root of 1 is 1. When x is 4, the square root of 4 is 2. Then we can fill in the other values, just square rooting these values. So we can plot these points. We have 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. And this is a continuous graph. We know we could calculate the values in between there. So we get something that looks like this. So explain why the domain of the function is not a set of all real numbers. We cannot square root negative numbers. So we can't include all the real numbers because the real numbers include negatives. We can't square root negatives. The domain of this function is x is greater than or equal to 0. The range is y is greater than or equal to 0. Oops. The reason we include the 0 is because of this point right here was 0.00. Square root of 0 is 0. So looking at transformations, well, we can quickly review all the transformations we know. We have vertical translations, horizontal translations, reflections in both axes, reflections in the line y equals x, or that's also known as the inverse. We have vertical stretches, and we have horizontal stretches. Remember, we have a certain order we apply these in. We have to apply stretches, then reflections, and lastly, we apply translations. The truth is you can really apply stretches and reflections at the same time. If you have a reflection, when you multiply, say, your x value by the stretch, you could multiply it by the negative stretch. Remember, though, for horizontal stretch, we do take the reciprocal from the equation. Excuse me. So in each case here, describe the series of transformations required to transform the graph of y equals the square root of x to the one given. We'll make a rough sketch, then we'll state the domain and range. So here we have y minus 4 equals square root of x plus 2. We could rearrange this to a more normal way of writing it, which is square root of x plus 2 plus 4. So our transformations here are left 2 and up 4. So the easiest thing to do is to take your vertex here, which was 0, 0, move it left 2 and up 4, so it's going to be about here. We have no stretches, so the shape is going to stay roughly the same. Or the shape should stay the same. Well, I can only draw it roughly the same. The domain and range, well, these tell you how your domain and range change. Your domain is now x is greater than or equal to negative 2. And your range will be y is greater than or equal to 4. B 2y equals the square root of negative x. So again, I could move that 2 over, which gives me this. So there's two transformations happening here. There's a vertical stretch by 1/2, and there is a reflection in the y-axis. Whoops. Okay, I'm struggling here. Reflection in the y-axis. So that x being replaced by negative x in the function means we multiply all of our x values by negative 1, which means it's going to reflect in the y-axis. So this is now going to look something like this. We multiply our y values by 1/2 and all our x values by negative 1. Well, how does that affect our domain and range? Well, it doesn't. Our vertex is still at 0. Sorry, it does, because now we're looking to the left, but it doesn't change it from 0. So now our domain is x is less than or equal to 0 because of the reflection, but our range remains the same. C, well again, I'm going to move that 5 over just so I get the y by itself. So now I see that I have a reflection in the x-axis because I have a negative sign here, so it's reflection in x-axis. That means I multiply all the y values by -1, and I go down 5. Now remember, we always do the reflection and then the movement. So when I reflect it, it would be here, but then I'm going to move it down 5. So this is where my final one ends up. And this would be at -5. So in this case, the domain has stayed the same, but the range is now less than or equal to -5 because it's moved down 5. So the stretches don't change the domain and range. The reflections, which is the sign of the domain and range. The translations are what switch the number of the domain and range. So here's the last one. This one we did in class as well. This one's tricky. If we think back to Unit 1, we need to remember to factor out that 2, that horizontal stretch, to tell us how we move. So what's happening here? Well, there's a vertical stretch of 3. There's a horizontal stretch of 1/2. That's where we take the reciprocal. And we also move right 1/2 a unit. So vertical stretch of 3 means we multiply our y values by 3. Horizontal stretch of 1/2 means we multiply our x values by 1/2. And then we move 1/2 a unit to the right. So what we end up getting is a very steep graph that looks something like this. So what is our domain and range here? Well, we've had no reflections, so our signs are going to stay the same. These are both going to be x is greater than and y is greater than. Our domain, we've moved right 1/2. So that's x is greater than 1/2. Our range, we are still on that axis. All we did to our y values was multiply it by 3. 0 times 3 is still 0. That's hard to see on your calculator. Your calculator has a hard time graphing something that's almost a vertical line, but not quite a vertical line. So it shows that there's no graph here, but there really is. So that's why it's important to know the transformations and apply them to the point. Example 2. Determine the domain and range of the function y equals a times the square root of b to the x if a is positive and b is positive. Well, if they're both positive, we only have stretches here. So we know that a stretch doesn't affect our domain and range. Only reflections do, and translations do. Okay, well, what if a is negative and b is positive? Well, if a is negative, that means we multiply all of our y values by something negative, which means we reflect in the x-axis, which changes our range. So our domain stays the same. We haven't multiplied our x values by anything, or by a negative number, maybe just a positive number, but that doesn't change it. That point will stay at 0, 0. But we will have a reflection in the x-axis, which means our range is now less than or equal to 0. What if the opposite is true? If a is positive, so that means we're multiplying our y values by something positive, but b is negative, so we multiply our x values by something negative. That now means we're going to have a reflection in the y-axis, which means we need to change our sign on our domain. So now x is less than or equal to 0. Our range is still greater than or equal to 0. Now they're both negative, so this means we're going to have less than signs for both. We've now reflected in both axes. So we have x is less than 0, y is less than 0.